And part of the problem here is these small bearings here. So those small bearings create a very small surface to pivot against here. And there's some play in those. There's some play in that shaft bearing. So as a result, when you get out here with massive amounts of leverage, you can really kind of bend it back and forth. So one of the things that we're testing is removing those and making this plate thicker, which should help things. Now we've eliminated the bearings in here, or we've eliminated the eccentric bearing for a double bearing system in here. That's helped the issue, but we're getting these plates refabricated so that the bearings are, the fit was oversized by about 1/1000th of an inch or so, and we need it to be press fit. So that's what we're doing in there. All right, so this is the old spindle design, and on the back here we have a ball bearing, and on the front here you notice that we don't have anything up front here. And so what was happening was, if I put this in backwards you can see it better, but you see how it wasn't really riding on anything right where the pinion is, and so that creates this nice little wiggle. So we wanted to create a gap there because we didn't want it riding on there. But what was happening was the whole pinion was wiggling and it was torquing out. What we've done with this new system is, if you look right in there, you can see that we've dropped a roller bearing right in there. So on the pinion gear, where the pinion is riding, we have a roller bearing that's going to take the load from the pinion and transfer it into the axle. Now when we drop it in here, we got a lot, we've pretty much eliminated the play. I can't move it back and forth, and that is going to speed up the, well, it's not only going to be a nicer roll, but it's going to basically ensure that it's straight up and down and we get good tooth contact. So I'm going to put these on the machine and we'll test them out from there. Alright, so now I'm just going to show you the roller bearing down here. So as you can see, everything is nice and flat. There's no tilting, and I can't really put pressure on here to try to tilt the axes, and it's not going anywhere. So we've cleaned up the teeth engagement over under here, and I'm just going to do a quick little roll test for you. So the thing rolls. The thing rolls easily with full engagement the whole entire time, and we are good to go. We should be good to go with the pinion here. Now we did some backlash tests with these, and the backlash came out under our quick backlash test came out under 5 thou. We got a couple more things that we're going to try, but these are within spec now, so we are good to go here. A note on tightening up the tensioner here. So when you tighten up the tensioner here, one of the things that you want to avoid is tightening it up too much, because if you tighten it down too far, the force of pressure on the spring pulling the teeth up into the gear rack is going to prematurely wear the pinion gear. And so what we're aiming for here when you tighten this up is to screw it down to the point where the pinion fully engages the rack teeth. So when I say fully engages, you can't wiggle it back and forth without moving the gantry. And then once you get to that point, give it a full turn more up here, and then you're good to go. Anything tighter than that, and you're going to start prematurely wearing the pinion. So that's about it for our rack and pinion test. And we should start shipping these immediately. If you have a kit, if you purchased a machine from us, and you're waiting on drives, we'll get those out to you here shortly. I'll be contacting you. If we haven't shipped your machine yet, these drives will start shipping standard with the new machines. Thank you.